So let's just kind of talk about how the week's gonna go. You just turned in your 1.4 worksheet, okay? I'll get those graded. It might not be tonight. I can't promise, okay? But you'll get them back before the weekend for sure. Today, we're gonna talk about section 1.5, literal equations. We're gonna need to practice it again tomorrow. And then we'll start reviewing Friday. We'll continue reviewing Wednesday because we have a 4-day weekend. You don't have school Monday or Tuesday. So Wednesday we'll finish reviewing. We map test Thursday, test on Friday. Okay. So somebody just asked me that. And I said that I can't remember which one comes first. Your guess is as good as mine. I think I heard it one day, but I can't really remember. So we'll be fine. All right, so this section, a little different. It's a little different. We are going to work with what we call literal equations. Okay, what is a literal equation? Okay, it's an equation with two or more variables. Okay, so instead of just having an equation with x and we solve for x, or y and we solve for y, we have an equation with maybe an x and a y, maybe a z thrown in there, maybe a b and an h, who knows? Okay, so there's going to be more than one variable. Okay, now you've worked with formulas before. Who can give me an example of a formula? How do you find the area of a rectangle?
Base times width times height.
So that's volume. Okay. Area equals length times width. That is an example of a formula, okay? A formula is a type of literal equation. That shows how one variable is related to the others. So it's just a special type of literal equation. We can plug numbers into it to find something specific, like maybe we're talking about area or volume, circumference. What's the radius? What's the length? What's the width? We have formulas for specific shapes and objects. Okay. You guys aren't working on anything like that in science, right? You guys are doing like genetics. Okay.
Well, actually,
What?
communication
Yeah.
on me.
Okay. Okay, so we are going to do the same thing that we've been doing in all of the other equations that we've been solving, where we basically need to isolate a specific variable and we have to move things over to the other side of the equal sign. Okay. It's just going to look different because not everything is going to be a number. Okay, so I want you to go ahead and look at the next page and look at number 1 right here. Okay, they want us to solve all of these equations for y. So do me a favor, grab your highlighter and highlight y. Okay, this is a skill that will be very important when we get to the next chapter, because we are going to have to graph linear equations and we're going to need to solve the equations for y. Okay, so in number 1, we want to get y by itself. Well, I see minus 2x right after it. How do I get the 2x to the other side? Colin? How do I get 2x to the other side? How is it being tied to y? Is it being subtracted? Is it being added? Is it being multiplied? It's being subtracted. So what's the inverse operation of subtraction? Okay, so we are going to add 2x to both sides. So this goes away. And we have y equals 15 plus 2x. Hey, we totally solved for y. Yes, we did. Now, your answer is going to look uncomfortable because it's not just a number. It's going to be an equation.
So when it says literal, you're solving for the equation, not the answer.
What? Equation, not, this is the answer. We're not getting a number for
That's
an
what I
answer.
meant.
We're
For
getting an
literal.
equation for an
For
answer.
literal. Equation.
Yes,
Okay.
we are literally getting an equation.
Oh, I got that one.
Okay, let's try another one. I can't remember which one I want to do. You know what? How about this? How about this? How about you just try it? Solve number 2 for me. All right, Gavin, what do we need to do with the 4x? We need to subtract 4x to both sides. Y equals 2 minus 4x. There it is. Okay. Now let's move on over to number 3.
Is it? Or do you not have to minus it?
I don't
Hey, let's do math.
have.
We are going to solve for y. Now, here is something different about this problem. This time, y has a coefficient. It's fine. It's really fine. Now, what needs to move first, the 8 or the 5? Raise your hand if you know. What needs to move first, the 8 or the 5? Avery. The 8. And how do we get it over to the other side? Thank you, Avery. We are going to subtract 8 to the other side. Now, let's think about what we're combining together. That subtract 8 is not going to get combined with the 5x because they're not like terms. It's going to have to get combined with the minus 2. So this is going to become 5x minus 10 equals 5y. Okay. What? Are you okay with this becoming 5x minus 10? Reagan.
Could it give you like +2 and then on the other side?
Technically, yes, but since we're solving for y, I want to get everything away from y. Yes. Yes. Who had a question? Someone else said they had a question. Seth, are you okay with this? Yeah? Avery?
Wait, so we're adding the 8, if it's like both subtract and then add it?
And keep that sign. So we're like -2 and we're going more -8. So now we have -10. Yep. Okay. Now to get rid of this 5 is attached to the y with multiplication. So we are going to need to divide both sides by 5. Okay, now let's think about what's happening here. What does this mean? This means that 5x is being divided by 5 and my 10 is being divided by 5. Right, Preston?
Yeah.
Okay, well, what is 5x divided by 5? Minus 2 equals 1.
Simplify.
We did simplify it. Yeah? Now we are going to come back to, oh, wait. We're gonna do one more. We're gonna do one more, and then I'm gonna hand out these pieces of paper. Okay. Let's go to number 5. 5's pretty important. We are solving for y, and this is a conversation I think is going to be good to have based on some of the things that have happened with like our quiz and stuff. All right, so that 3x needs to move away. How do we move it over? Colin. We are going to subtract 3x. It is a positive 3x. Now, let's talk about that minus sign, Gus. That minus sign is still stuck on the y. It hasn't gone anywhere. It's still there. We moved the 3x, but that minus is still there. So we have a minus y. Okay, we haven't solved for y yet, have we? So we need to divide by that negative 1 to get y equals, let's do this, negative 4 divided by negative 1 minus 3x divided by negative 1. So we end up with 4 plus 3x. What?
So it just basically switches the signs.
Yes, it switches the signs. And that's a good way to think about dividing by a negative or multiplying by a negative. If we have multiple terms that's happening for, it's just going to switch the signs. Okay. How about you give number 6 a try while I hand out this yellow piece of paper. Try number 6. Does require your pencil to be moving and your eyes to be on your paper. You're trying number 6. Because he was thirsty. Check in with your neighbor. Whether you're done or not, just check in on their progress.
I don't know.
She's struggling.
You don't know what to do? Okay, so what did you do?
You can't divide
Did
by
you- Yes, so since why you're here.
Shit, well, that wouldn't mean anything. Well, if you divide by positive, four, it'd be a negative.
Divided by -4.
You would want to divide by -4.
Huh?
You'd want to divide
That's
by
what I
negative.
thought. Okay.
Your first step should be to subtract 7 from both sides. That should be your first step. Check in there.
What?
Oh, yeah.
We actually figured it out. And I did something.
Why?
All right, so let's talk about how we do the next step, okay? Because I think the next step kind of has people a little nervous. What is our next step?
Divide by -4.
Okay, now make sure that that negative stays with the 4. Now we need to divide by -4. So we have 3x divided by -4 minus 6 divided by -4 equals y. Okay, 3 divided by 4, that it doesn't happen. So we're just gonna leave it as -3/4 x. We're just gonna leave it like that. Okay, now this turns into an addition, right? Negative. 6 divided by 4 is the same as 3 divided by 2. And you know what? We are totally cool with improper fractions. We are totally cool with improper fractions. They're actually going to help us. I'm not going to be picky about the decimals right now. Somebody just shut my door.
Being too loud, Miss Rue. Miss Rue.
Miss Rue.
I said Miss Rue, not
Now-
Miss Rue.
Now me personally.
What's my name, Colin?
No, Miss Rue shut the door. Yeah.
Oh, it was Miss Rue that shut the door. I thought you were telling me I was being too loud, and then you called me Miss Rue, and
No, I
we
was
were
saying-
about to.
No, I was saying that you were too loud. Miss Rue shut the door.
Miss Rue is taking kids into the hallway, I think, so that was very kind of her. Okay. If you guys put decimals for this chapter, I'm totally fine. Okay, next chapter, nope, in 2 chapters, when we start talking about lines, then we'll talk more about what we need to do, like graphing lines. That's chapter 3. All right, we're gonna come back to number 8, but what I want to do right now is I want you to grab the yellow sheet that's in front of you. So keep your journal open because we're coming back, or Maddie, that's fine what you did. Okay. Now, here are kind of some hints for you. Okay. Remove fractions by multiplying by the reciprocal. Work backwards from PEMDAS. The last step is probably going to be to divide by a coefficient. Maybe. Okay. What do you notice about these 6 equations here? Okay, they have fractions.
They have a.
What is this a for? What is this? What is this? They're formulas. What is this a formula for? Triangle area. What is this a formula for? Some sort of volume of a cone.
Half circle.
This should look familiar right here, right?
Oh, sir.
Celsius and Fahrenheit.
No.
No, that's not familiar. No, it's a different measurements for temperature.
Wait, Sophia, you know you were.
So this is Fahrenheit, this is Celsius. Yes. All right, so let's look at number one. Let's look at number one, the area for a triangle. Okay. Let's go ahead and solve for H. Okay. 1/2 times B times H. All three of those items are being multiplied together. That fraction, I'm just kind of done with it. How do I get rid of that fraction?
Multiply.
Multiply by?
1 and then divide by, no.
Half.
What am I going to multiply by to get rid of 1/2?
I was thinking multiply by 1 and
Multiply by 2. What's 2 times 1/2? Yes. So we're going to multiply both sides by 2. So wrong.
in my thoughts.
Okay. So 2A equals BH. Is Holden okay with that? Okay, what's the problem, Holden? It is weird. So maybe I have the area and the base of a triangle, of many triangles. And so if I solve it here, then I can just keep plugging into the formula with H already solved for and save myself work later on. Avery.
Wait, so 1/2 is going to the A, right? Like it's.
So like 1/2 is being multiplied to the B multiplied to the H. So to get rid of it, instead of dividing by 1/2, we just multiplied by 2 so that 2 and 1/2 would multiply to cancel out. Okay. All right. Now, if I want to solve for H, how do I get rid of B? We're going to divide by B. So H equals 2A over B. Yay. It's the exact same thing we've been doing.
It is.
We just don't have numbers all the time. But I know, guess what? That's why we got to practice. That's why we got to practice. Okay. Go back. Do you see some similarities between number 1 and number 2? Okay, there's a V instead of an A, but they look pretty similar, don't they? Okay, let's highlight B. That's what we're going to solve for. That's what we're going to solve for. Anna, what would you do first? Times by what? Yeah, we're going to multiply both sides by 3 so that 1/3 and 3 cancel out and we have 3B equals BH. That's excellent. Okay. Aiden, what's our last step? Divide both sides by what?
H.
Well, we're solving for B. So maybe we should divide by H. And capital B equals 3V over H.
Doesn't matter on the back one. It's lowercase.
If it's in the formula, it better stay the same way. You know what? I'm going to give you 60 seconds. 60 seconds to see what you can do with number 3. If you fail, we're doing it with a eraser.
Kick down the corner.
I would not do that. What is happening over here?
Surgery.
Do you need to throw it away?
You can still use it.
Once we go on our own.
What's my name?
This helmet, I'm so sorry. I was thinking about what Colin said. I swear.
Hey, did you say Drew?
I did.
Yes.
I did.
I mean, I feel like maybe we could look similar. Although she has red hair and I do not.
I called Mr. Wilkinson my dad last
It's
year,
red
so I mean,
hair.
it's not that
Or I'm
bad.
colorblind.
You guys don't
Yeah,
look the
she
same.
did that. Me and Mr.
Yo, me personally. Personally, I not take it that level of
How does that make you feel?
Colin, I thought we had a good thing going. Andrew, what is our first step?
Times it by 2.
Let's multiply by 2. So we have 2k equals mv squared. Raise your hand if this was what you had. Okay, good. Now, what are we solving for?
I'll let you.
So if we're solving for m, then we would need to divide by v squared. So m equals 2k over v squared. Preston, on that green sheet, what time do we get out of here on Wednesday?
I think it's the same.
It's like right next to you.
This moment, I'm
It's
sorry.
the same.
It's not.
Too late. You already have.
Yeah, because we skipped 5.
36. Okay, thank you. Colin, I knew you were kidding. I don't think Colin has a mean bone in his body. All right, let's look at number 4 right here. Number 4 is very interesting. We are going to solve for B. So I want you to think about, do we need to move D or C first? Please raise your hand if you vote for C to be moved first. Please raise your hand if you vote D to be raised to be, yeah, you're right. Okay, because D is tied to the whole thing. We need to get rid of it first. And Amy, how do we get rid of it? You got multiply. So DA equals B plus C.
It doesn't have to be dark.
Oh, here's a lovely thing about multiplication. It is commutative. So if you write DA or add, they mean the same thing. Sorry, I shouldn't say it. DA is the same thing as AD. Okay, either one's fine. Now to get B by itself, we're going to need to subtract C over to the other side.
Oh,
Feels like I'm just writing letters.
You are.
So this is I like math better than
So I tell you what, if you can survive with me a couple more examples and you can do your homework, I have like a game that we will play tomorrow where we practice these. I'll make these boring equations a little bit more fun. But if you can't cooperate with me, I'll just give you a worksheet and y'all make you be quiet. And you can raise your hand if you have a question.
That's crazy.
Okay. All right. Number 5. I am blowing your minds today because you didn't know there was a conversion for this thing called Celsius. If you, sorry, Amy did. If you know what the temperature is in Fahrenheit, you can plug it into this formula and convert it to Celsius. Now, most countries use the metric system, which is Celsius. We're the weird ones. Okay, so raise your hand if you think we should move the 32 first. Raise your hand if you think we should move the 5/9 first. Okay, good. We need to move the 5/9 first because it's tied to the whole thing. Okay. Gosh, how are we going to get that 5/9 over there? Okay, now don't write this. I love that we need to divide by 5/9, but man, Colin, that's pretty ugly up here. So instead, let's multiply by the reciprocal, the flip. 9, because those will cancel. I'm blowing minds. Let's do this. You know what? I'm blowing minds too quickly here. Let's do this. How about, since we're dividing by 9, we multiply by 9. So we have 9c equals 5 times f minus 32. Now, how do we move the 5? So now 9/5 c equals f minus 32. Yes. You can do this in 1 step or 2. I was blowing too many minds. I didn't want brains to start falling out. So I broke it up into 2 steps. You decide what works for you. Okay. Now we're going to add 32 to both sides. So now, if we have a Celsius, and see, this would actually be beneficial. Let's say that you're in Europe, because why not? And you check the temperature outside and it says 32 degrees Celsius. And you're like, no, you're other way around. Oh, yeah. You could plug 32 in for C and calculate what the degree is in Fahrenheit. Okay.
What would it be?
Whatever 9/5 times 32 plus 32 is. Sorry. Yes.
Maybe once we go to Germany. I'm in Europe. I'm just gonna look up.
Come back to number 8. Okay, I need you to just be quiet and listen to me. So back in your student journal, we're going to number 8. There are some things that we're going to do in this class that you think, why the heck are we doing this? Okay. A lot of Algebra 1 is to prepare you for the next classes you are going to. Okay. Now, if any of you are people who think that maybe you want to go into something like engineering or architecture, or, you're going to need calculus. Okay. A lot of you might end up taking calculus. If you don't have these basic skills that you need for calculus, that you would need for your career. Yes. Now, this right here, we're eventually going to be graphing lines where I need you to solve for y. That right there is going to be something you're going to have to do over and over in chapter 3, just so you can graph a line. So we're practicing it now. That way, when we get to chapter 3, you're like, "Whoa." No, we know how to do it. Okay, let's look at number 8. You guys are fine. Stop whining. Stop whining. Oh my goodness. We have 3 minutes, and this is the most difficult problem. Just shut your traps. Look up here. I have 2 X's. Oh my goodness. What am I gonna do? Watch. Watch. I'm going to undistribute.
Yes. Great.
X times 3 is 3x, and x times 9z is 9xz. So since I had 2 different x terms that I couldn't combine together, I rewrote it to a distribution problem. Now it's tied by multiplication.
Oh, did you get divide?
And x equals q divided by 3 plus 9z. Okay. So I undistributed the x. Are you good with that, Elliot? I undistributed, so I took this, and since there was an x in each of them, I wrote it out here and made it a distribution problem. So now this parentheses is being multiplied to x, so I divided both sides by it. You know what? I think you have one problem like this on your homework. We will talk about it first thing at the beginning of class tomorrow. How's that sound, Estelle? Estelle, is that okay? Did you hear me? Try every single homework problem. It's in the book. It's already posted in Google Classroom. Try every single problem. But we will talk about the one that looks like this first thing tomorrow.
First thing first,